Bismillahirrahmanirrahim. Today's exercise is exercise 14.2. Now to start with, we are going to read question number 1. Question number 1 is that you are given a triangle ABC. In triangle ABC as shown in the figure, CD bisects angle C. CD, this is the bisector of angle C. It means this CD is dividing this angle C into two equal halves. And the given measurements are BC is equal to 10, AC is equal to 12, and AD is equal to 6, and you have to find the value of BD. You have to find this length. Now in this question, the theorem with the help of which we are going to solve this question is theorem 14.1.3. okay, to start the solution we will start with theorem 14.1.3. okay, what was theorem 14.1.3? It was that if you have a triangle, okay, A B C, and there is a bisector of angle C, then the statement was that the internal bisector of any angle of a triangle divides the side opposite to it in the ratio of the lengths of the side containing the angle. In simple words, what they are trying to say is that if you have a bisector CD of any angle of a triangle, okay, you have a triangle ABC, you take an angle and you draw the bisector of that angle. If it happens to be the bisector of the angles, if CD is the bisector of the angle C, then it will divide this side AB, which is opposite to C. okay, this bisector will divide AB in such a way that the ratio between these two segments will be the same as the ratio between these two sides. okay, the ratio between the segment AD and BD will be the same as the ratio between AC and CB, the side containing the angle whose bisector you have drawn. okay, so this is the statement of theorem 14.1.3, which we have already discussed, and we have proved this theorem also. So yes, using this, the statement of this theorem, now what we are going to write is that this is CD is the bisector of the angle C, so it will divide this AB in such a way that AC, measurement of AC over measurement of BC will be equal to measurement of AD over measurement of BD. This is because of this theorem 14.1.3. okay, this ratio between the segment is always equal to the ratio between the other two sides. okay, so now they have given us AC, they have given us the length of BC, which is 10, and they have given us the length of AD, which is 6, and they want us to find the length of BD, which is X. So doing the cross multiplication, we are going to get 12x is equal to 6 into 10. Now the value of x will be 6 into 10 divided by 12, which will give us x equal to 5 centimeter. So it means that this length is equal to 5 centimeter. So you are going to choose the option. They have given you different options in this question, and we are going to choose the option in which the length of BD is written to be equal to 5, which is the first option. okay, so the length of BD will be equal to 5. Now moving to the next question, question number 2. Now in question number 2, they have given us triangle ABC, okay, and they have given us the CD bisects angle C. This is angle C, and this is the bisector of angle C. Now AC is given to be equal to 3, BC is given to be equal to 6, and they have given us this whole length to be equal to 7. And they want us to find AD and BD, okay, AD, okay, and BD. These two lengths are unknown. We know that AD plus BD is equal to 7. This is given to us, and we have to find AD and D. Before this, let us suppose that let AD be equal to X. Suppose this is X, then if this length is X and this whole length is 7, then length of BD, we know the length of BD is equal to AB minus AD, that is 7 minus X. So this length will be 7 minus X. Again using the same theorem, theorem 14.1.3. using theorem 14.1.3, which states that if you have a bisector which is dividing the opposite side into two segments, then the ratio between these two segments is always equal to the ratio between the sides containing the angle. So ratio between 3 and 6 will be the same as ratio between x and 7 over x. That is measurement of AC over measurement of BC. Okay, the two sides is always equal to measurement of AD over measurement of BD. Now AC is equal to 3 over BC is equal to, given to be equal to 6. We had supposed AD to be equal to x and BD was 7 minus x, because this whole length is 7. This is equal to 7 minus x. We are going to do the cross multiplication, and then we are going to solve it for the value of x, which will give us the length of AD and BD. Okay, so cross multiplying these two, 3 into 7 minus x is equal to 6x, that is 21 minus 3x is equal to 6x, and 21 is equal to 6x plus 3x, which is equal to 9x, and x will be equal to 21 over 9, which is equal to 2 point divided by 9 will be equal to 2.3. Okay. Now to x is equal to 2.3, it means measurement of AD is equal to 2.3 centimeter, and measurement of BD, we know the measurement of BD is equal to AB minus AD, AB minus AD, which is equal to AB was 7 minus 2.3, this is approximately equal to 4.7. Okay, so the measurement of BD is 4.7 and measurement of AD is 2.3. That is what we had to find, and this completes the solution. Now in this question we are given triangle PQR, and again we have a line AB which is parallel to the third side of the triangle QR, and it is intersecting the remaining two sides. So according to theorem 14.1.1, this line will cut these two sides proportionally, means the ratio between these two segments will be the same as the ratio between these two segments. So it is given that PA is equal to 8x minus 7, this is 8x minus 7, PB is 4x minus 3, okay, AQ is 5x minus 3, and BR is 3x minus 1, and you have to find x, and it is given that AB is parallel to QR. Now according to theorem 14.1.1, you can see the statement that if a line is parallel to the one side of the triangle and it is intersecting the other two sides, then this line will intersect the other two sides proportionally. It means that it will cut these two sides in such a way that the ratio between these two segments will be the same as the ratio between these two segments. So according to this theorem, PA over AQ will be the same as PB over BR. That is PA, what is PA? 8x minus 7 over AQ 5x minus 3. This will be the same as PB, what is PB? 4x minus 3 over PB over BR, which is 3x minus 1. This is because of this theorem, okay, that the statement which I have told you today, and we have already proved this theorem, I think, but the statement of the theorem we have already done that the ratio between these two segments will be the same as the ratio between these two segments. So we have to find the value of x. From here what we are going to do, we are going to cross multiply these two fractions, and then we are going to solve the equation which we will obtain as a result of this calculation. So doing the cross multiplication, 8x minus 7 into 3x minus 1 is equal to 4x minus 3 into 5x minus 3. Okay, cross multiplication, these two brackets will be multiplied and will be equal to the product of these two brackets. So multiplying these two equations, what we get, 8x into 3x will be 24x square minus 8x minus 21x plus 7 is equal to 20x square minus 12x minus 15x plus 9. Now shifting this, first of all let us add these two. Minus 29x plus 7 equals to 20x square minus, this will be equal to 27x plus 9. Shifting these to the left hand side, what we will have, 24x square minus 20x square minus 29x. Shifting this to the right hand to the left hand side will give us plus 27x, and 7 minus 19 plus 7 minus 19 equals to 0. Subtracting these two, we will get 4x square minus 29x plus 27x will be minus 2x, and 7 minus 9 will be negative 2. Taking 2 common from this, what we get is minus 1. Okay, and shifting 2 to the right hand side, dividing both sides by 2, we will get 2 will be cancelled out from here, and 0 divided by 2 will be 0. So we are going to get this expression. Now we just have to solve this. Solving this by factorization, two numbers whose product is negative 2 and whose sum is negative 1. What are the two numbers? The two numbers are negative 2x plus x minus 1 equals to 0. These are the two numbers whose product is minus 2 and whose addition gives us negative 1. So 2x, taking 2x common, what we get, x minus 1 plus, again taking 1 common from these two, we are going to get this x minus 1 into 2x plus 1. Solving these equation, x minus 1 is equal to 0, the product of two numbers is equal to 0. It means that at least one of them should be equal to 0. Either this will be equal to 0 or that is equal to 0. Okay, we have to take both the possibilities. So x will be equal to 1 or x is equal to negative 1 by 2. So the values of x are x is equal to 1 and negative 1 by 2. These are the two values of x, and this gives us the answer to this question. Now moving to the next question, we have the next question is, we have triangle LMN, and LA is the bisector of this angle. So it means that we will be using theorem 14.1.3. We have a bisector of this angle, and we know that this bisector will divide this length MN into two segments such that the ratio between these two segments is always equal to the ratio between these two sides, according to theorem 14.1.3. We are given the length LM to be equal to 6, LN is 4 centimeter, MA, this length is equal to MN, this whole length is equal to 8. Okay, MN is 8, and we have to find MA. Again, we are going to suppose it to be equal to x. If this length is x, obviously this whole length is 8, so this length is going to be 8 minus x. Okay, and then we are going to use this theorem. So now starting the theorem, let AM be equal to x, then this implies that AN, which is equal to MN minus AM, will be equal to, MN is given to be equal to 8 minus, this is x, so this will be 8 minus x. AM is x, putting its value. Now applying this theorem, the ratio between LM over LN will be equal to MA or AM over AN. So LM is given to be equal to 6, LN is 4, MA we have supposed it to be equal to x, and AN we have according to that is 8 minus x. Now cross multiplying both the equations, what do we get? 8 minus x equals to 4x, and we are going to multiply in this bracket. is equal to 4x and 48 will be equal to 4x plus 6x, which will give us 48 to be equal to 10x, and this implies that, let me write it here, x is equal to 48 by 10, which is equal to 4.8. So it means that MA is equal to 4.8. Okay, and AN is equal to MN minus AM. MN was given to be equal to 8 minus 4.8, and the result will be 8 minus 4.8 going to be 3.2 centimeter. So this is the answer, and this completes the solution for this question. Now let's move to the next question. Now here in question number 6, we are given that PQR is an isosceles triangle. Triangle PQR is an isosceles triangle, and if it is an isosceles triangle having these two sides equal, and they have asked to find the value of x and y. Now we know that if this is an isosceles triangle, it means that two of its sides are going to be equal. So PQ is equal to PR. It means we know that PQ is 10, so PR is also going to be equal to 10. 10 equals to PR is x. So from here we have obtained that the value of x is equal to 10. Now this is a line which is perpendicular to the third side. Okay, whenever this is a line, whenever we draw the angle bisector of this in an isosceles triangle of this vertex angle, these two are the base angles. Okay, and these two are the equal angles, and this is the third angle in the isosceles triangle. Now the angle bisector of this is always cut the side opposite to it into two equal halves. Okay, this is in the properties of isosceles triangle, that the angle bisector always cut these two cut this side opposite to angle P into two equal half, and it also cut it at right angles. Okay, this is from the properties of the isosceles triangle. So it means that if I take this point to be equal to, what have they taken it? If this is the angle bisector of, if this is the perpendicular line, then this must be the angle bisector of this angle P, and it always divides the side opposite to it into two equal halves. Okay, the ratio of these two sides will be the same as the ratio of these two sides. If you use theorem 14.1.3, the ratio of PQ over PR is the same as the ratio between, let me take this point as D, QD over DR, because this is the angle bisector, and in an isosceles triangle this perpendicular is always the angle bisector. Okay, if it is cutting the third side and perpendicularly, then this must be the right bisector of the side also, and this is also the angle bisector of the angle which is opposite to this side, QR. So PQ, this is the angle bisector, so PQ over PR will be the same as QD over DR. So PQ is equal to 10. PR is also equal to 10 because both these sides were equal. QD is 6 and DR is what we have to find, Y. Okay, so cross multiplying these two, 10Y will be equal to 60, 10 into 6. So Y will be equal to 6, and this will give us the values of X and the value of Y. X is equal to 10 and Y is equal to 6. So in this question we have just used the property of the isosceles triangle, that we know that the right bisector of this side is always the angle bisector, as well as this angle bisector of this isosceles triangle always cut the side opposite to it at right angles. Okay, if it is the right angle, if this is the line joining P and D, then it must be the angle bisector of this angle P. And this completes the theorem, the solution of the question. X is equal to 10 and Y is equal to 6.